Without much ado, it is my honor to introduce to you our guest speaker who will be engaging us through her presentation on automation system for fry production. Our guest speaker for this afternoon is the Center Chief of the Bureau of Fisheries and Aquatic Resources, National Freshwater Fisheries Technology Center. She is also a recipient of the Overseas Development Authority and British Council Scholarship Program for Master of Science in Aquaculture degree at the Institute of Aquaculture, University of Stirling, Scotland, United Kingdom. She is also currently taking her doctorate in fisheries technology at Iloilo State College of Fisheries. She is also the focal person or BFAR focal person for National Tilapia Program. She is also the Philippines focal person for Food and Agriculture Organization State of the World Aquatic Genetic Resources. She is also a co-project leader and a proponent and co-proponent of 7 collaborative research projects, such as in NFRDI, DA Fisheries, Biotech, and DA-BAR. And she is also in charge of the continuous broodstock development of IXL, iBest, cold and red tilapia. Ladies and gentlemen, let us all welcome our guest speaker for this afternoon, Ma'am Maria Jodecel C. Danting. Good afternoon, ma'am.
Good afternoon, Angelo. Thank you very much for that kind introduction.
Okay, so we will be having, in a while, we'll be having the presentation, and I would like to invite our FB Live viewers to drop their questions, or we'll be entertaining or addressing some questions after the presentation. So, without much ado, let's now keep the ball rolling.
po ngayon ibabahagi sa inyo ay tungkol sa automation system for intensive fry production of tilapia. Ang technology po ng automation system para sa intensive production ng tilapia ay dinesign upang ma-maintain po sa optimum range ang water quality parameters gaya po ng temperature, dissolved oxygen at iba pa pong mga parameters na kinakailangan para po sa reproduction ng tilapia. Dito po sa technology na ito ay may mga sensors na gagamitin para po ma-detect ang state ng water parameters na under control at para po ma-provide ng signal o input to control po yung mga display devices gaya po ng Arduino board. So ito pong tinatawag na Arduino board, ito po ang siyang babasa na inputs and in turn po ay magiging pong output. Like it may say ng activate yung water pump motor and support ng mga instructions. So on the other hand, yung water po will be monitored, it will be recirculated, and it's a principle of RAS na ipapalo po dito para po sa mas effective at mas efficient na maintenance ng mga water parameters aside po sa conservation po ng ating tubig. At automated hatchery po natin ay powered po ng solar power energy para po sa continuous operation. Ang impact po ng ating automation system na ito ay para po mapataas ang production ng tilapia fry. Magkaroon po tayo ng year-round supply ng fry at fingerlings. Ganun din po para mapaikli natin ang grow-out culture period. At kasama dun po dito ang pag-improve natin ng yield ng tilapia resulting po sa mas mataas na kita ng ating mga fish farmers. So at present po, ang ating pong beneficiary ay ang National Tilapia Breeding Nucleus o ang DA-BFAR-NFFTC para po sa upgrading ng kanilang facility at ang village level nursery and grow-out farms po sa CAR, sa Abra, Apayao at Benguet, then sa Region 3 po, sa Pampanga, Nueva Ecija at Tarlac, na siyang magiging mga recipients po ng mga na-produce na fry at fingerlings. Ang project po na ito ay ating pong ginawa upang makakontribute po sa DA's twin objective of reducing poverty and achieving po yung food security. At ang highlight po nito ay para ma-upgrade yung hatchery production facility ng BFAR-NFFTC. Ganun din po particularly, kaalunsad ito sa farm mechanization and infrastructure investment, technology and innovation, kasama po dito ang digital agriculture and climate change adaptation and mitigation measures. Ang paggamit po ng traditional pond-based tilapia fingerlings production ay simple lang pong gawin. Subalit, may mga several disadvantages po ito na ating na-experience kagaya po ng inefficient use of pond area at yung vulnerability po ng ating mga seed stock para sa predation. At may mga remarkable low fry and fingerling production po din po tayo sa mga panahon po na meron tayong extreme weather condition. So sa pamamagitan po nitong automation system, ito po ay matutulungan tayo para ma-ensure po yung year-round supply ng ating quality fry and fingerlings na ating pong pwedeng ipamahagi o distribute sa ating mga nurseries at grow-out farms sa mga panahon po na ang ating pong temperatura ay beyond sa optimum level for reproduction. Ang main objective po natin sa proyektong ito ay para po ma-enhance natin ang supply ng quality seed stock ng tilapia sa pamamagitan po ng paggamit ng automation system para sa intensive fry production. Then, ang ating po mga specific na objective ay para mapataas ang hatchery production po ng quality tilapia fry by 30 to 40% through upgrading po ng ating intensive tilapia hatchery facility. Ganoon din po para ma-establish natin at ma-strengthen ang linkages po between the National Tilapia Broodstock Center po natin at ang mga nurseries at grow-out operators. And then, para din po ma-validate ang cost efficiency ng paggamit ng automated intensive tilapia hatchery by 20% increase sa ating profit. Ano po ba ang pagkakaiba ng automation system sa regular modified intensive tilapia hatchery facility? So, ang isa pong pagkakaiba nito ay meron po itong tinatawag na ground heat exchange system. Meron din po itong filtration at aeration system. Aside from that, ay meron din po tayong tinatawag na additional hybrid solar power system para po masuportahan yung energy for the operation of the automation system. Kasama rin po dyan ang shading structure at of course yung pong sensors and data logger. Paano po ba ginawa ang ating automation system na ito? Una po, dahil existing na po ang ating tanks, so we just repair po yung ating tank at yung mga drainage system. Nagkaroon din po tayo ng mga minor repairs gaya po ng pag-level ng tank bottom at pag-repair po ng mga drainage system. So more or less po, natapos ang activity na to within 2 weeks period. Next major activity po ay yung installation of ground heat exchange system. Basically, ang ground heat exchanger system ay isang sistema na bibisang napapanatili ng temperature ng tubig. So ginagamit ito ang natural heat from the ground to generate water temperature that is cooler than the surface water temperature. So sa pamamagitan po ng collaboration natin with Central Luzon State University, ang ground heat exchanger system po ay na-construct at the adjacent pond of the tank kung saan po ay unang hinukay po ang pond bottom sa pamamagitan po ng backhoe equipment at doon po ay installa yung ating heat exchanger system. So ito pong system na to ay consisted of a 4 inches diameter na PVC type or pipe with a total length of 78.2 meters. At ang initial depth po ng pipe is 1 meter at ang final depth po is about 2.5 meter. So this is to take advantage of the natural gravity para po mapanatili ang maayos na sirkulasyon ng water or ng pond water sa ating system. At the end, ay yung standpipe po ay connected at the end of the system to serve as the mini reservoir for the return of water to the tanks. Right after the installation of the heat exchanger system ay ang installation of the filtration system. Generally, ang ating filtration system ay may tatlong components. We have the first stage where the solids will be removed. Then next, the second stage where the water will pass through the filter media beds, microfiltration, where the biological filtration system will do the work. And then lastly, we have the third stage of the filtration or the clarifiers. This is with the aid of activated carbon and fiber wool to further filter the pond water. So, kung ma-observe po ninyo, mayroon tayong different filtration system and this is to ensure that the pond water is clean before entering the ground heat exchange system. Kasi po, ang tendency, once na mayroong suspended solids na makapasok sa ating ground heat system, ay magkakaroon po ito ng clogging, which is magiging problem po ng ating setup. So, na-discuss na po natin ang tank system, ang ground heat exchange system, at yung din pong filtration system. Now, dadako naman po tayo sa fabrication and installation of the aeration system, particular po ang air lift system. So, ito pong air lift pumps are commonly used in the aquaculture system basically po to circulate water at mag-provide po ng dissolved oxygen. At the same time, ang main component po ng air lift system is a PVC pipe and an air blower. So this kind of aeration system also aids the water circulation within the pond system. Isa sa mga components na ating automated hatchery system na aking nabanggit kanina ay ang hybrid solar water pump. So, ito po ang picture ng ating hybrid solar submersible pump ay para po ma-avoid ang fluctuation of power supply. Therefore, yung pong system will automatically tap from the AC power supply for continuous work. So this pump system will aid the circulation of pond water through the filtration setup to the ground heat exchange system, then pump back water from the ground heat exchanger system to the tanks. Aside from the ground heat exchange system, another innovation, especially from the Central Luzon State University, is yung pong integration ng aquashade technology. So dito po, gumamit tayo ng straw net with 70% shading capacity. So sa ganito pong paraan, ito po ay effective sa pagpapababa ng water temperature at around 3 to 4 degrees centigrade tuwing tag-init o katirikan ng araw. Nababawasan nito ang negatibong epekto ng sobrang pagtaas ng tubig na nagriresulta ng pagbaba o pagkawala ng produksyon tuwing dry season. Ito po ang automated part ng hatchery facilities. Since kailangang i-maintain ang angkop na temperatura sa pangingitlog ng tilapia at dissolved oxygen ng tank system, mag-i-install po tayo ng sensors para automatic na po na mamomonitor ang temperature at dissolved oxygen ng tubig. Yung mga readings po na ito, mare-record sa ating data logger, then maproprovide naman ng signal sa ating control device. Dito po, naka-program ang optimum level ng temperature at dissolved oxygen. So kapag beyond the optimum level na po ang temperature at ang DO, magsesend po ito ng signal sa ating system para mag-on ang water pump at air blower para po ma-address ang kalidad ng tubig in terms of temperature and dissolved oxygen. So kaugnay din po nito, ay magsisend ang ating system ng readings ng temperature at DO sa cellphone through text message. Na-discuss na po natin ang pagbuo ng automated hatchery system. So ngayon naman po ay dadako tayo sa tilapia hatchery operation using po itong automation system natin. So similar lang din po ang practice. Yun lamang po sa preparation ng tank at conditioning ng breeders, except na higher po ang stocking density sa ating automation system. So generally, we were able to stock the system with an area of 300 square meter with a total of 1,237 na tilapia breeders. While dun po sa ating control tank o yung ating pong original na modified intensive tilapia hatchery ay nilalagyan lamang natin ito ng 612 tilapia broodstock. Ang egg at fry collection po ay ginagawa 10 days po after nating mailagay ang ating mga breeders. And then it is being done at 7 days interval. Then yung mga collected eggs po natin ay itinatransport sa ating artificial incubation facility. So more or less po ay 5 to 7 days sila dito sa ating incubation facility. After that period, once po absorb na yung yolk, ito pong ating mga swim-up fry ay pwede na pong i-stock sa Pine Mess Nursery Hapa na may dimension na 5 by 3 by 1 cubic meter at the rate of 1,005 per square. Kung kaya po ang ating rearing hapa o nursery hapa ay pwede nating lagyan ng 15,000 na fry. Dito po ay makikita natin ang actual egg at fry na kinolekta sa ating dalawang production cycles. So, comparing po yung dalawang system, mas mataas ng 30 to 40% ang automation system kaysa po sa ating original na modified intensive tilapia hatchery. So, specifically, an increase of 82.9% during the first cycle and around 68.5% during the second cycle was achieved using the automated system. Dito naman po ay ipinapakita natin yung ating percent survival from egg to fry stage of tilapia coming from the two systems. So the recorded survival in automation system is around 80.7%, while 45.8% naman sa original na modified intensive tilapia hatchery. So that's around 76% increase in terms of egg survival. Dito naman po ay ang water quality parameters reading sa dalawang system. So when it comes in temperature, nagdi-range ang water temperature sa 27.8 to 30.2 degrees centigrade sa ating automated system, while 28.8 to 32.6 degrees centigrade naman sa ating control or original na modified intensive tilapia hatchery. So that's around 2 to 3 degrees centigrade lower. So naglalaro naman ang dissolved oxygen sa 1.3 to 9.5 parts per million sa ating automation system, while 4.6 to 12.8 naman sa ating original na modified intensive tilapia hatchery. When it comes naman po sa pH, ammonia, nitrate at nitrite, ay comparable lang po ang dalawang system. Sa pamamagitan po ng project na ito ay ating pong establish at strengthen ang linkages between the National Tilapia Broodstock Center at sa mga nurseries at grow-out operators po natin. So as of now, we were able to identify na po yung mga cooperators nitong project na ito in coordination po sa ating mga regional tilapia focal person dito po sa Cordillera Administrative Region at sa Region 3. Then, dalawang nursery co-operators at dalawang grow-out operators na po ang ating na-cater kung saan 50,000 tilapia fry na po ang na-distribute per co-operator sa ating nursery. At para naman po sa grow-out ay nakapag-distribute na po sa co-operator natin sa Tarlac ng 20,000 pieces na tilapia fingerlings. Sa project din po na ito ay ating pong i-validate ang cost efficiency ng automated intensive tilapia hatchery. So ang target po natin ay ma-increase ang ating profit o tubo by 20% using the automated intensive tilapia hatchery at 10% increase po in profit sa ating nursery and grow-out operators. So para po sa status, nasa baseline data collection po tayo dahil ongoing pa po ang conduct ng ating mga trials using this system. To simplify po itong ating table, with regards po sa projected production for one breeding cycle, especially po yung stocking density, dito po sa ating traditional na modified intensive tilapia system, ang stocking density lamang po ay 1 hanggang 3 piraso bawat square meter. However, dun po sa ating automated system, ang suitable stocking density po ay 4 pieces per square meter. So in total po, para sa mga breeder requirement for 300 square meter area, ay 300 to 600 pieces po para sa traditional na modified intensive tilapia hatchery system kumpara po sa 1,200 na piraso para po sa ating automated system. Then with regards po sa spawning success, meron tayong 35% dun po sa first two system while 40% naman po para sa ating automated system. Now, moving po dun sa ating fingerling production, per female breeder, 100 to 500 eggs per female breeder po ang ating projected. Ito po yung naunang system, while 500 egg per female naman po para sa ating automated system. Then with regards naman po sa or estimated nating hatching rate, ang fry production po and survival rate from fry to fingerling as well as sa fingerlings for disposal ay comparable naman between the two except po sa estimated fry production and dispersal by around 100 to 150 higher in the automated system. Now, moving naman po tayo sa feeding and water management. Ang main difference po ng ating automated system ay meron po itong automatic feeder with appropriate na DFR and then yung utilization po ng automated sensors and also the automated water exchange. So to wrap it up po, from this project, I were able to upgrade the intensive tilapia hatchery facilities for modified intensive tilapia hatchery at BFAR-NFFTC. Pag-conduct din po tayo ng 2 production cycles with a total of 359,600 and 3,500 eggs and fry collected, giving us an increase of 82.9 and 68.51% during the first and second cycle respectively. So nalagpasan po natin yung 30 to 40% increase in terms of production na ating pong target. Then, ganun din po, nakapag-identify po tayo ng ating mga indirect beneficiaries. Meron po tayong 3 nursery cooperators at 3 cooperator in Region 3. We were able to distribute a total of 100,000 pieces na fry sa ating pong nursery cooperator at 50,000 fry para po sa ating grow-out cooperator. So in the pipeline po ay we are continuing the gathering of baseline data on our production. Importante po ito para po ating ma-estimate yung ating cost-benefit analysis. Further, activities po, especially on the production, are being conducted para po ma-compare natin ang dalawang systems po. Ang susunod naman po ay ang video presentation nitong ating project on automation of intensive tilapia fry production upang mas or lubos po nating maunawaan ang ating pong project na ito. Thank you.
Okay, thank you so much, Ma'am Maria Jodecel C. Danting. We have played the video a while ago. Siguro po ay napanood na ng ating mga FB Live
Nauna.
viewers. Thank you so much for the very comprehensive presentation po. Meron lang po akong ilang mga katanungan dito, maybe in behalf of those who are watching, na hindi po na ilagay yung kanilang mga tanong maybe on the thread or on the comment box. Anyway, with the very much convincing concept of the study, because if I got it right po kanina, no, ongoing pa po tayo sa ating data analysis and all. But then looking at the concept po, no, sobrang ganda. In fact, you've said or you've presented a while ago na yung target po natin na 20% increase in the profit and then another 10% doon naman sa growers ay ma-achieve po natin simply by using or adopting this technology. Ngayon po ang katanungan maybe for those who were so inspired o na-convince po, kaya lang hindi ganoon ka-financially capable maybe or baka hindi pa sila ganoon ka-ready mag-set up ng ganitong klase ng technology. I have enlisted yung 5 systems po that you have enumerated a while ago, such as the GHES, the filtration system, the airlift system, the hybrid solar water pump, and the shade net. Now my question, ma'am, is, dun sa mga gustong mag-umpisa, syempre, di ba, unti-unti po yan. Alin po kaya dito sa mga components ng automated system yung pwede nilang i-prioritize if they would like to venture in or to adopt the technology?
Okay, sir. Sir, good afternoon po again. And I'd just like to introduce po yung mga kasama ko dito, yung mga kasama natin sa project with Milagros Apaga, siya po yung ating study leader, and Engineer Alvin Jimenez. With that question, ang ating pong ipa-priority is yung shading po. So with this climate change that we are experiencing at the moment, ito po yung nakita namin na malaki po yung impact. Like, ito pong technology na ito ay tested nga ng FAC Central Luzon State University, and we really can testify that this is about 2 to 4 degrees centigrade po yung nadi-decrease pagka po meron tayong shading. Malaki po kasi ang epekto nung pag tumataas ang temperature sa ating mga water quality parameters po.
Ayan, thank you so much, ma'am. Also to all our FB Live viewers na na-inspire po nung setup ng automated system or automation system rather. So ang ipa-prioritize po natin if we would like to have a startup is the construction of the shade net. Now to keep that going, ma'am, maybe second and third after the shade net or construction, ano pa po kaya yung pwede nilang unting-unting idagdag and eventually adopt this kind of technology?
Okay. So yung next po, I think, is yung applying the RAS or the recirculating aquaculture system. Kasi by having this, we can conserve water. At the same time, magagamit natin or maximize natin yung usage po nito. And this is an intervention para po dito sa climate change.
Ayan. Thank you so much, ma'am, for the comprehensive answer po. So I hope our FB Live viewers got those answers and feedbacks and inputs as well. And my last question, ma'am, is I know this is kind of out of the topic or the study itself, but the question goes like, can there be any chance po of having this type of technology be adopted to other species po? Like maybe may mga nakikinig po na hindi naman tilapia yung kanilang inaalagaan.
I think so, pwede po siya, sir. Since yung tilapia po is a hardy fish, so this can serve as a parang a model setup po ito, itong ginawa natin sa tilapia. And this can be tried dun sa other pong species natin na with aquaculture potential din po.
Okay, maraming salamat po, ma'am, for being very generous po sa inyong mga sagot. Thank you so much, ma'am. I guess we do not have any more questions. Once again, thank you so much. Yes, ma'am, if you would like to add.
Yes, sir. Thank you very much din po for inviting us.
Okay, maraming salamat po along with your staff members, to the entire project team po. So moving on, okay, we would like to award the certificate of appreciation. Okay, papakita ko lang po muna ngayon. Anyway, we'll be sending, mahirap, ayan. We'll be sending po the signed certificate. So the Department of Agriculture Bureau of Agricultural Research awards the Certificate of Appreciation to Maria Jodecel C. Danting for sharing her invaluable knowledge and skills during the webinar titled Automation System for Intensive Fry Production of Tilapia, held in celebration of the Bureau's 35th anniversary. Given this day, second day of August 2022 in Diliman, Quezon City. Signed by our very own director, Dr. Janelle B. Soriano. Once again, ma'am, maraming salamat po. And we will be sending the signed certificate.
Thank you
Maraming
very
salamat.
much. God
Okay.
bless you.
Okay, maraming salamat. And sa amin po mga FB Live viewers, we would like to request you to stay here kasi this is just the first. We still have one. That's next. But then anyway, maraming salamat po ulit Ma'am Maria Jodecel C. Danting along or to the rest of the project team as well.
Oh, sir. Thank you ulit.
Okay, maraming salamat po. Okay, sa ating po mga FB Live viewers, before we go on to our next presentation, please share our live. Please follow us as well on our FB page. And we also have our Instagram account.